Lesson 6-8, Day 2. Our first question says solve the system of inequalities by graphing. You may notice that both of these inequalities are written in standard form. So before we graph them, we need to convert those equations into slope-intercept form. So what that means is we want the y by itself on the left-hand side of our inequality. So I will subtract x on both sides. That leaves me with negative y is greater than negative x plus 5, because we want those terms in slope-intercept order. Now the negative sign in front of the y really represents a negative 1. So my next step, I need to divide by negative 1 on both sides of the inequality. What happens when I divide by negative 1 is I have to remember to flip my symbol. So y is less than positive x minus 5. So I start my graph at negative 5 on the y-axis. My slope is 1. So rise 1, run 1, up 1 over 1. And I can draw my line. Looking at the symbol, I know that this would be a dashed line because it's less than, and it's shaded below. So dash my line. And then shade it below, which would be this section right here. Now my second equation, 2x plus 3y is less than or equal to negative 6, is in standard form again. So I subtract 2x on both sides. 3y is less than or equal to negative 2x minus 6. And then I divide everything by 3. So I have y is less than or equal to negative 2/3 x minus 2. So I start at negative 2, and my slope is negative 2/3. So down 2 over 3 to the right. And this line is going to be a solid line. And it's less than or equal to, so shade it below. So the region that is shaded twice is right here. Any of those ordered pairs in that region would be considered a solution to the system. So any of the ordered pairs. My next system, the first equation is almost written in slope-intercept form. I just need to do one thing, and that would be divide everything by 2. So y is greater than negative 2x minus 3. So I can start out at negative 3 and go down 2 over 1. This is going to be a dashed line because the symbol does not have a line underneath it. It's simply a greater than symbol. And greater than would be shaded above the line. So this side right here. My second one is in standard form. So it requires a little bit more work. Subtract 3x on both sides. 2y is less than or equal to negative 3x plus 12. And then divide everything by 2. So y is less than or equal to negative 3/2 x plus 6. So I start out at 6 and down 3 over 2. Looks like this. So, as you can see, I don't have nearly enough room to get these two to intersect with each other on my graph, is that I would have to keep going in this direction. And this is going to be a solid line. So they are going to intersect at some point, but on my graph, you're not seeing that. And it's less than or equal to, so it's shaded below the line. So the good news is, shading below this line, you do see the solution region. It's just that I would like it to be, I would like you to see the point where they intersect with each other, and you just can't see that from this graph. So, the region in between them, up until where they intersect with each other, is your solution. It's been shaded twice. Now the next couple of problems, these are really, really important because on a multiple choice test, like your MCAs or when we're map testing, you may have some systems graphed for you, and you have to figure out which one is graphed correctly. So you may notice that both of these lines, they look the same in each of the graphs. It's just the shading part that has changed. So I'm not questioning whether or not they've been graphed correctly. It's the shading piece that you have to be able to figure out. So I'm going to take this first inequality and I'm going to put it in slope-intercept form just because I want to be able to look at that symbol. Okay, so y is greater than or equal to negative 2x plus 4. So negative 2x plus 4, so this line is correct, it's a solid line. Greater than or equal to would be shaded above that line, So if I shade above that line, I know that A is wrong because this piece right here tells me that they didn't shade above, they shaded below the line. So this first line has to be shaded above, like the right-hand side. So this one, so this looks like it's been shaded correctly, and so does this. This one, definitely not shaded correctly. This one, not shaded correctly. Okay, because it had to be shaded above that line, above the line, like that. So it's not A and it's not B. Now the second one, if I subtract x on both sides, 2y is greater than negative 1x minus 4, and then divide by 2. So y is greater than negative 1/2 x minus 2. So negative 2, negative 1/2 x. So both of these lines that I have left are graphed correctly, but which side should be shaded? If the symbol is greater than, it should be shaded above the line. So here's what I'm talking about, above this line. So D has to be my solution. This one right here is not shaded above the line, it's shaded below. So it's not C, it has to be D. If it's too confusing for you to look at the 4 options of multiple choice, please graph the system on your own and then compare your answer to the 4 choices and see which one is correct. So if it's confusing or overwhelming to look at A, B, C, and D, graph it on your own separately and compare. The last question says, name a point that would be a solution to the system of inequalities that you see graphed. Well, the solution is going to be the green region. So any point in the green region, because yellow and blue make green, so any point in the green region is going to be a solution. So I'm going to give you some examples of points that are in the green region. Right here, 3, 0 would be a good solution. Maybe 4, negative 2 would be a good solution. maybe this point, 5, 4, you could use. So hopefully you get the idea. Any ordered pair that is located in that region that was shaded twice, so in this problem, it's the green region, any ordered pair in that green region is a solution to the system of inequalities. You do not have a summary to write today, so you are ready to work on your homework problems.